All right, so I'll be doing a bunch of physics problems that have to do with kinematics. If you're taking AP Physics, C Mechanics, classical physics in a college course, or if you're planning to take them, please take a look at this video. It's going to show you what you're dealing with. So our first question is: a watermelon is thrown up into the air and reaches a maximum height of 20 meters. From this height, how long will it take for the vegetable to fall to the ground? Ignore air friction, treat the watermelon as a particle, and assume g is going to be equal to 9.8 meters per second squared. You have brown here. The slants indicate that the ground is not moving. This is our watermelon, and the height from the ground is going to be 20 meters. So we're just looking for the time it takes for the watermelon to reach the ground, and you have to use one of the kinematics equations to solve for this time, which is going to be this. The final height is going to be the initial height plus the term initial velocity times time plus 1/2 the acceleration times time squared. So let's rationalize what our terms are. So this is the final height. We want to look for the time that it takes for the watermelon to fall to the ground. So you know that it's going to be 0. For the initial height, it's 20. The only force acting on the watermelon is the force of gravity. There's no other force that's going to cause the watermelon to have an initial velocity in the y direction. So this is 0, and thus this term cancels out. And a is going to be equal to g, but we need to look at what signs we're going to use. Since our initial height is going to be 20, g has to be negative. So this is going to be negative 9.8. All right, so we just write out our values. And we're just solving for t. We'll bring this term to the left side. We know 1/2 of 9.8 is 4.9. So we just divide 20 by 4.9 and square root the term. Which is going to give you 2.02 seconds. So it's going to take the watermelon 2.02 seconds for it to reach the ground from 20 meters above the ground. All right, here's our second problem. You flick a penny from the top of a 50-meter high building, giving the penny a horizontal velocity of 20 meters per second. How long will it take for the penny to reach the ground? And what distance will the penny travel from the edge of the building measured horizontally? Ignore air friction, treat the penny as a particle, and assume g is equal to 9.8 meters per second squared. So the penny is here, and this building is 50 meters high. So you're solving for two unknowns: the time it takes for the penny to fall to the ground, and how far the penny will reach from the edge of the base of the building measured horizontally, which is denoted as d. So we just solve for the first unknown. We just use our kinematics equation for the y direction, right? Y is going to be initial height plus the velocity initially plus 1/2 a t squared. So the penny is going to fall to the ground, which has a height of 0. The initial height is going to be 50. The only forces that acted on the penny is going to be the force of gravity and the force of the hand that flicked the penny from the building. which only gives the penny a horizontal velocity. There's no vertical velocity, so that's going to be 0. And A is going to be negative. A is equal to G. And since we assume the initial height is going to be 50, G is going to be negative. So it's negative 9.8. So let's write our numbers out. You know, 1/2 of 9.8 is 4.9. We bring this term over to the left. You divide 50 by 4.9 and square root the whole term to get t. And you're going to get 3.19 seconds. So let's rationalize this answer. So the penny is 50 meters above the ground. It's going to take 3.19 seconds for it to fall to the ground. So our second unknown is how far it will reach from the base of the building. So we use our kinematics equation in the x direction. X is going to be the final x position. It's going to be the initial x position plus the initial velocity plus the acceleration. All right, so you know that we know d is going to be x minus xo, x naught. I'll just write out here. So if we subtract x naught from x, we know that this is the change in x, and we're solving for d, so the change in x is going to be d. And you know that the acceleration, there's no acceleration given to the penny, it's only given an initial velocity. So we know this term is going to cancel out. This is going to be the time that we solved for the first unknown, right? Bring that over, and we know that the initial velocity given to the penny is 20 meters per second. So D is going to be 20 meters per second times time, 3.19. So D is going to be 63.9 meters. All right. Hello, here's another physics problem. A Molotov cocktail is thrown at an angle 30 degrees above the horizontal with an initial velocity of 15 meters per second. So the first part is asking what's the maximum height that the Molotov will reach. This will be right here. This is when the horizontal velocity of the Molotov will be 0. So we first convert these the velocity into its vertical and horizontal components. For this problem, for this section, we're just solving for the horizontal velocity. This is going to be v sine of theta. Plug our numbers in. Velocity is 15 meters per second. Our angle is going to be 30. And then it will come out to be 7.5 meters per second. So we're given the vertical velocity, and we know that at this point, gravity is the only force that's acting on it. So we have to use this kinematics equation. So you should already know this. It's given to you. This is the final velocity. This is the initial velocity. That's 2 times the acceleration times the change in height. This change in height is the maximum height that we're solving for, assuming that the Molotov is initially thrown from a height of 0. Cancel that out. 0 is going to be 7.5 squared plus 2. Since 7.5 squared is a positive, that's the speed, A will be equal to G, and it has to be negative since it's decelerating the speed. Change in height, we just denote that as H. Solve for H. just add this term over to the left and then divide h by this term for both sides. Answer is going to be 2.87 meters. So the maximum height that the Molotov will reach will be 2.87 meters. All right, second part, how much time would the Molotov spend in the air? So there's two components that we could use. The first one is time 1. Second part is time 2. And we could use our kinematics to solve for time for for both these halves. So the first half is when the Molotov is thrown with initial vertical velocity, right? This is one of the kinematics equation. At this point here, the velocity will be 0 for the vertical direction. We're given g. This is going to be negative 9.8, so we just solve for t. Isolate for t. Number 5 divided by 9.8. Plug in your calculator. Your time for that is going to be 0.765 seconds. This is time 1. All right, time 2. So how much, it's basically asking how much time it will take for the Molotov to drop from this height. We're already given the height, so we just solve for the time. At this point, the velocity will be 0, so this cancels out. Since this is a change in height, or h, the a is going to be equal to g. It's going to be positive since we don't want a negative time. One half of 9.8 is 4.9. Just solve for t. It's going to give you 0.765 seconds. It's going to be t2. So the time we're solving for is t1 plus t2. This denotes the total amount of time that the Molotov will spend in the air. So these are both the same value, so just multiply by 2. I'll just add it here. Answer is going to be 2.53 seconds. All right, third part, what horizontal distance does the Molotov cover? So we know the time that it will spend in the air is 1.53 seconds. So we will use this time to compute the horizontal distance that the Molotov covers using one of the kinematics equations for the horizontal direction. Final x is going to be initial x plus the horizontal velocity initially. There's no acceleration, so we ignore that. Let's solve for this first. We just use our trigonometry. It's going to give you 12.99 meters per second. So we know that x minus x0 is going to be the change in x, or just d, the distance that the Molotov will cover horizontally. So d is going to be equal to initial velocity in the horizontal direction times time. Let's plug our numbers in. Your answer is going to be 19.9 meters. So the total horizontal distance that the Molotov covers will be 19.9 meters. And the time it takes for it to do that is 1.53 seconds.